And welcome everyone to today's session. It's all about environmental sustainability for construction and infrastructure. My name is Dr. Aaron Yardley and I'm delighted to be here representing Tunley Environmental. In today's session, we'll be covering a brief introduction and then we'll be going on to the requirements and accreditations. We'll also be looking at carbon management plans. So we'll begin with the standards and guidance. We have altogether quite a few standards and guidance which we can follow in terms of reducing emissions in the construction and infrastructure. The first, ISO 9001, is quality management, ISO 14001, the environmental management. These are the two general standards which set up really the basics of what's needed for all the others. In construction, lots of buildings, there are brilliant accreditations out there now. These three here, BREEAM, LEED and USGBC, are three green building standards and sort of rating systems that have emerged to be the leaders. Many companies are wanting to strive to achieve good ratings for. Now the last two, RICS and PAS 2080, these are more standards. So RICS professional statement and whole life carbon assessment. This is important in considering both operational and embodied carbon emissions. RICS is the methodology to follow, whereas LEED and BREEAM are the accreditations where you try and get ratings. PAS 2080 at the bottom is a globally applicable standard. This focuses on managing and reducing carbon emissions throughout the entire life cycle. We've got BREEAM, we've got LEED, we've got RICS, and we've got PAS 2080. And that's why we'll come on to this section now, all about the REBA stage of works. In this section, we'll delve into this and we'll start to think about the concept of a whole life cycle carbon assessment. These are absolutely essential for doing the calculations to achieve the four standards which we talked about before. These are like a plan of works that outlines the stages of a construction project. We go from the inception, the idea, the preparation of a brief when you're in a boardroom actually first discussing about it, all the way through to the final, to it being completed. So it's divided into 8 main stages. Here we show the 5 main stages what are needed for any sort of calculations which are included in the RICS WLCA. And why might you want to go for these? Well, obviously for the benefits. So we want to really understand how carbon accreditations help the construction and infrastructure. Essentially, they help you become committed towards a sustainable development and environmental future. So first of all, sustainability, it attracts customers. It also has cost savings. They can optimize processes, they can improve resource efficiency, and the benefits are not just environmental because they increase these efficiencies. They also improve customer satisfaction, and overall, the accreditations ensure high quality projects. Carbon management plan. It's what is required. It is the absolute essential to really make a difference. The carbon management plan, it's all about planning projects well, and it's crucial for setting foundations for carbon reductions. It shows here in this figure that essentially the earlier we set a carbon management plan, the earlier we do the calculations, the more potential to carbon reduction we've got. On one extreme, right at the start, you plan, you find out that you actually don't need it, you've saved 100% of the emissions because you built nothing, you've got other alternatives. But obviously, more than likely, you start to build less, build clever, and build more efficiently. So your actual potential of reducing will be somewhere around here, but you consider it right at the start. Whereas if you get to the end, the construction, the operation, the maintenance, we've already started building the building, we've already started putting in everything what we need. Any changes then will cost too much. The structure of a building has already gone up. We can't change it. So the earlier that we set a carbon management plan, the earlier we start to think about it, the more potential we've got to reduce emissions. The planning stage is absolutely crucial. It sets a foundation. So how do we do this? We do this with something called a whole life cycle carbon assessment. It helps us evaluate and manage the total carbon emissions associated with a construction project throughout its entire life cycle. So it's from A1 to A3, all the way through to the end of life. Material extraction, all the way through. We've got to make sure that we define the scope, so then we know exactly what's included in the project. So identify the boundaries. Is it just that one building? Is it two buildings? And then what is important to us? What stages are important? Ideally, it'd be all the stages. And then we can start to collect the data and measure the carbon footprint. So you use the collected data and you calculate the carbon emissions. This involves very well established carbon calculations, exactly like what's in standard business carbon assessment. So you take the data, you make sure it's in the right units, you multiply it by the emission factors, and then you sum everything up and get the tons of CO2. Once you've done the calculations, you can identify reduction opportunities and then implement the strategies. So what might the results look like? Might look a little something like this. So we've got each stage here. We've got the embodied carbon stage, A1 to A3. This is the raw materials, the transportation, the manufacturing. And if we look at two different types of heating, we've got a natural gas boiler and an electric heating. At this embodied carbon stage, we're looking at the materials, what go into each of them. So what goes into a natural gas boiler, the materials, you're talking about the casing. And then we start to look at where these raw materials come from. How are they mined? What emissions are produced from it mining? The transportation of them to be manufactured. So the boiler has to be manufactured. It's the manufacturing, the mining of the raw materials, transportation to the boiler manufacturing site, and actually making the boiler. And we've got this A1 to A3, and then we've got the transportation to site, A4. So this is like transporting the boiler, it's all made, the electric heater, it's all there, transporting it to somebody's house or to a construction site. A5 is the construction stage. So how are the boilers, the heaters, how are they installed? Whereas when it comes to maintenance and repair, according to these results, the natural gas boiler requires a lot more maintenance and repair during the use phase, the B stage, B2 and B3. It uses a lot more. It also needs replacing, the natural gas boiler, whereas the electric heating does not. And towards the end, you add up all the results and you get a total carbon footprint. And then we've considered everything from A1 all the way through to C4. So, successful implementation. What does that look like and what are the benefits of it? In the end, you get accurate carbon footprint results. Right, the final stage is to actually look at some real life examples. Next, I'm not sure if anybody recognises this building, but this is in Manchester. It is the One Angel Square. This one, for the cooperative group, this one was certified BREEAM Outstanding and LEED Platinum. Again, absolutely exceptional sustainability credentials. But what I liked about this one is that it also did PAS 2080. The One Angel Square focused on this whole life cycle carbon approach. It considered design all the way through to the end of life, doing each scope, each stage. It helped the project achieve specific targets, like it wanted to minimise embodied carbon by so much. It had a rigorous design analysis, and it also managed to reduce a lot of waste. So the benefits of actually implementing PAS 2080 were huge. Collaborated across the whole entire value chain, reducing carbon emissions, and it also aligning to the UK government sustainability goals. So again, this building itself is it's a model for sustainable construction. It is one to be proud of. We have also got the Bank of America Tower in New York. This one again did BREEAM, got BREEAM Outstanding, and it also got LEED Platinum. So again, another very impressive building. This one also adhered to the PAS 2080 in exactly the same way. It uses a lot of responsible source materials. Remarkably, it's reported that over 90% of the waste generated was recycled or reused, which is absolutely incredible. It's got its own combined heat and power plant within the building, so it generates its own electricity as well as its own heat. So essentially, the building contributes to its own sort of sustainability. It's got a rainwater harvesting system, collecting rainwater, using it in toilets, irrigation. It's got a green roof, uses natural ventilation and daylight. And again, it's another really exceptional building to showcase what can be done. We also have one in Japan. So I thought this were an important example to show you, because not every building has to have LEED or BREEAM to actually be a good example or a prime example of sustainable design. This one in Akasaka in Japan. This one is certified under the CASB, the Comprehensive Assessment System for Built Environment. And this one has a high rating of S. So you can see that different accreditations have different ratings. So this CASB is most popular in Japan. It's a comprehensive system and it evaluates the environmental performance of buildings and built environments exactly the same way as LEED and BREEAM. So it wants to enhance the quality while reducing lifecycle resources. And essentially, the Akasaki city building incorporates several key design features, which include things like a green roof, energy efficient lighting, rainwater harvesting, natural ventilation, and it uses eco-friendly materials, lots of recycled materials, that sort of stuff. In conclusion, we finally conclude with CPD. One of the main things to take home is that being an environmentally sustainable SME in the construction and infrastructure sector can be difficult. It really can, but it can also lead to a large number of benefits. Reducing the environmental impact can go hand in hand with improved cost efficiency. By this, it just takes a lot more planning and implementing. But if you do it early, then it doesn't have to cost you a fortune to actually implement environmental technologies. You do them right from the start, you can find ways where you can reduce and become more sustainable. The main thing is consideration. Look into it. So by implementing these sustainable practices, you can reduce your carbon footprint, which helps mitigate the effects of climate change and protect environmental for the future. Whole life carbon assessments are the absolute key. They're the tool to really measure the environmental impact, and they can help identify where to reduce emissions early in a project. There's certifications such as BREEAM, LEED, with standards such as PAS 2080, which you can work towards and validate these sustainability credentials. So if you're already doing the work, you're already doing the calculations, or somebody else is doing the calculations for you for the project, then share it. Get the accreditations you deserve. And finally, the economic benefits. Thank you, everybody, for joining today, and I look forward to receiving any questions